Good evening, all. On behalf of the Chennai chapter of the Indian National Academy of Engineering, I extend a cordial welcome to all of you this evening to the first lecture in the webinar series organized by this chapter on an R&D Road Map for Indian eMobility 2022 to 2030 to be delivered by Mr. Karthik Athmanathan, Senior Vice President, Ashok Leyland, and Professor of Practice at IIT Madras. I especially welcome the speaker and thank him for agreeing to give the lecture almost immediately on our invitation and request. I also welcome all the members of the Chennai chapter of INAE and all fellows of INAE, INAE Young Associates joining from other chapters, and all fellows of INAE, all invitees and participants, and also the INAE office staff. IIT Chennai chapter was recently reactivated with the informal forming of the executive committee with me as president and Professor Nandita Dasgupta as secretary. But IIT Chennai chapter had been quite active even much earlier with two annual conventions held three annual conventions held in 1997, 2003, and 2017. And also we have conducted the National Frontiers of Engineering once, the Engineering Conclave on the twin topic of Engineering Education 2020 and Smart Cities in 2016 in IIT Madras. And we had also organized an INAE CATS joint conference on international engineering education in 2007. With this brief introduction, it is now my pleasant duty to introduce the speaker of the evening. Just 1 second, so that, I just want to introduce Professor Karthik Athmanathan. Karthik Athmanathan is Senior Vice President at Ashok Leyland and is also currently a Professor of Practice at IIT Madras. At IIT Madras, he is developing and launching a web-enabled multidisciplinary MTech program in mobility, as well as starting various projects jointly across academia, industry, and the government. At Ashok Leyland, he has handled projects like the eMobility, Captain Cab, Sunshine School Bus, Circuit E-Bus, and the High Bus Hybrid Bus. He was the chief engineer for buses, cabs, and load bodies, and also managed the product development for Optare Leyland subsidiary in the UK, world pioneers in electric and hybrid buses. He was also the head of Ashok Leyland's e-mobility business and has been in the forefront of electrification of commercial vehicles in India, helping Ashok Leyland win many awards in the e-mobility space for innovation. Now it is my pleasure to welcome Professor Karthik Athmanathan to deliver his lecture. But before that, the lecture may go for about 40 to 45 minutes with a question and answer session at the end of the lecture. And Professor Shankar Rao will be moderating the question and answer session. So the participants can raise their questions in the chat box, as well as, if possible, at the end of the lecture, if somebody wants to ask the question in person, they can raise hand and ask the question. Thank you. Professor Karthik Athmanathan, please.
Thank you, Prof. Good evening, everyone, and good to be giving you this talk today. I just had a few points to make before we finally get into the R&D Road Map. I'll get down to it straight away. First, I thought I'll use some time to set the context, because in India, research and development is very frequently interpreted in a great many ways. We will learn to define it, and we will have to learn to define it, and we'll have to start following a certain protocol across the country in all sectors. Then we'll rush through the market segment details and the costs and volumes. We'll also rush through the technology trends. We will not spend too much time there. then focus a little bit on the skilling needs that are required to make e-mobility happen. That's just about starting, and I'm part of that in IIT Madras. And finally, the main topic, the research and development agenda for e-mobility. What are the good areas to focus, and where will be the maximum benefits at a country level? It's not at a company or a institution level. It'll be at a country level. And also some administrative levers, which I have learned from other countries, so that for the R&D projects, we can look at some administrative levers for that. So that's the sequence. So setting context, first of all, I wanted to put a few warnings in the beginning. See, first of all, e-mobility is an evolving area. We read a lot about it in the papers, and we think it's all over the world and omnipresent already. But in reality, it's just starting globally, and it's got a long way to go. And because it's an evolving area, new technology, new supply chains, everything is happening on a quarterly basis, things are changing. So we need to keep that in context when we look at this entire presentation. And because of this constant change, which is not true for ICE engines, or if you look at construction industry, there are quite a few mature technologies there. Here it is not yet mature. It will take another 7 to 10 years to mature globally. It makes sense to understand and appreciate that what you see and hear today will be a combination of estimations and perceptions, which is just not mine, but also a compilation of other people who do research in this area. And finally, because it's a very difficult domain, please don't hang on to these points for more than a year. It needs careful and constant reevaluation, and you need to manage it. So that's part of the R&D plan. So it's a little difficult or different from other areas which are already mature, right? So first, I'm sure a lot of us know about technology readiness levels. Everyone has heard of this, TRL1 up to TRL9, starting from basic research, going through prototypes, functional prototypes, and then representative prototypes. And then you've got your validations, your pilot production, and techno-economic validation. So these are TRL levels. Globally, I think this started with the International Energy Agency, I'm not sure. And it's now become a pretty global thing. There are a few interpretations of this, but essentially this is the broad flow. The reason I'm showing this is because this is the first time in e-mobility, India has not only the opportunity, but the need to work in initial research phases. If we don't do this, in spite of all the investments, it is going to keep trailing other countries. So if you want to be one of the global leaders, research, intellectual capital is an important part. And in intellectual capital, you don't plan quarters, you plan sometimes decades, but mostly at least 2-3 years as a horizon. So I just wanted to highlight that using this slide. So what exactly is research and development? I've taken the example from the National Science Foundation in Virginia, probably the most well-defined one as on date. So first, basic research is all about doing things for the sake of knowledge, scientific knowledge. There's no other purpose. Knowledge is its own purpose there, right? So you do basic research. It may or may not have specific commercial or social objectives, but you go into it for the purely for the sake of scientific knowledge. A good example is gravitational waves, right? As of today, it is knowledge. It's not of much utility for all of us, but we know that such projects end up giving you phenomenal advantages down the years, down the decades. So this is basic research, and it may or may not succeed, right? It's a very esoteric area for most people. So you go on to applied search, which is a part of it as well as a derivative of it. So what applied research does is it has very clear objectives that are related to business and society. So it is to be used for a purpose, right? So that becomes applied research. It does have a higher level of probability for success compared to basic research, because the fundamental knowledge is probably already generated in basic research. A good example as of today for electrical engineers, variable flux motors. This is a good example as of today. The next phase is called development. So the research stops here. In development, what you do is basically you go through a very structured activity using the knowledge from research, and you produce prototypes, useful materials, devices, systems, methods. It could be in any area. So functional prototypes are produced. Remember, these are functional prototypes. These are not complete final prototypes which will be validated for durability, etc. And finally, the probability of success in this phase is higher because the fundamental research is completed. There's more to be done, and that's what is being done in development phase, but the probability of success increases. And next phase is engineering. Now, this is typically where the companies come in and business takes over this activity. So this is basically the design and preparation of marketable goods or marketable processes. They're legally compliant. They'll satisfy the laws of the land, and the success is pretty much guaranteed because most of the technical problems at a product engineering level is completed. Now it is process and other aspects which are addressed. This is the engineering department in most companies, right? And finally, its probability of success is, as I told you, higher than what it was. So after that, we go to industrialization, and this is where the rest of the work gets done. Things like supply chain, aftermarket readiness, production facility, market launch, etc. So this is a process-oriented, very rigid activity in most companies. It's done with a concrete business case and a budget and a time plan. And after that, you have your ongoing business. It keeps running. So I hope this gives you a rough idea. Now we go to R&D success. So how are we for success, right? So if you look at global data from research to ongoing business, as of today, majority of industries have only 15% success. So the balance, 85% of the projects, they either fail in terms of result or the time frame or the cost of development. So this is an important part. So the risk of failure is high, but then the returns are phenomenal if you do this part of the work. So 15% success in terms of result, time, and cost, but another 15% succeeds if you give it more time and a little bit more money. So you come to about 30% success in terms of achieving your objective, either with delays or minor cost overruns. So 30% is the global success rate if you want to look at it overall over a period of time. And in some sectors, there is an extra factor of success. So another 20%. So what is true for e-mobility may not be true for engines today. And what is true for, let us say, pharmaceutical may not be true for construction industry. So this 20% is the variance, but whatever it is globally, it's between 15% and 50%. So it's not something which you're really going to go beyond 50%, right? But if you catch the project at the development phase instead of at the research phase, this we are good at. India is probably the best in terms of very frugal and very good practices. In a way, you could call it the Indian independent rediscovery of the wheel. But believe me, this is important. I'm not trying to belittle it here. This is a very important activity, and India is very good at this. And we are also good at adopting it and developing it as new knowledge in India, either acquiring it or working further on it and improving it. So this is good, and this is 90% success. We are in line with global capabilities here, and we are at satisfactory levels, acceptable levels. But what's important is for global leadership, we need to be in the first space, the research space. And there we have been lacking in the e-mobility area. Not enough, and definitely nowhere near impactful. So that, I hope, gives you some context about what R&D is. Now we move on to the markets and volumes and costs. As everyone knows, e-mobility is going to take off rapidly, and it has started taking off. So if you look at 2030 figures, it is really, I think, close to 10 times current volumes. So in 9 years, 8 years, you're going to be seeing 10 times the number of electric vehicles which you see globally. And in India, it will probably be more because two-wheelers and three-wheelers are the norm here. Similarly, battery demand also, it keeps going up till 2030. So this is not new to any of you. It's pretty well known. And if you look at EV adoption in India, I'll just focus on a few of the products. This is just India, mind you, not the global norm. Wherever e-rickshaws have been permitted by the state government, they are a complete success, runaway success. E-rickshaws are the product for the country. And wherever the state government has permitted it, it makes money sense to the passengers, it makes money sense to the operator, it makes money sense to the environment. So very, very good ecosystem. The only thing that is holding back e-rickshaws is state government policies where they are seeing them as a threat for other businesses or other licenses in the state. So having finished e-rickshaws, you go to two-wheeler, three-wheeler autos. These have also seen cost parity and they've started booming, especially in the goods sector. In fact, they're doing so well that they are eating into your Tata AS, those kind of markets. Next, after that, you see the light commercial vehicles taking off. After that, you see the two-wheelers taking off without subsidies. So what happens is the two-wheeler rider starts seeing money sense. India, 95% of two-wheeler sales is to people who look at it as a means of living and as an important cost to be managed. So all the fancy scooters, they have their own market, but this is the fundamental thing. This market, if it takes off, the volumes will come. So that's expected to happen in the next 1.5 years. And after that, you have the light commercial vehicles starting off in 2024 and buses becoming viable in 2025. Right now, you see all these EVs because of the government subsidies and the schemes, and which is good because it establishes the ecosystem. But the buses by themselves, to become viable, they need more time. And then you look at cars and finally trucks. Surprisingly, there is a lot of push for electric trucks of late, not yet by the government of India, but a lot of foreign companies are now coming here, not as businessmen, but as NGOs. And they are trying to enable zero emission trucking for the sake of the environment. So whatever it is, most of us in this business believe that government regulation, upfront cost and financing, and the total cost of ownership, these are the factors which will allow any specific segment to take off, not just incentives. It will not continue. It cannot be sustained by the government. The government is providing the subsidies purely to enable the ecosystem, and then it will move out after the budgets are finished. So how will India look in 2025 is what this slide is. This keeps changing, mind you, every year. I've had to make my own changes as well. This is from Avendas, a financing company, equity advisory firm. So what they've given is a pessimistic scenario, an optimistic scenario, and in blue, a realistic scenario. So in 2025, they're expecting 9% of two-wheelers to become electric. And India produces, believe me, 20 million vehicles. So 10% of that is 2 million two-wheelers in 2025 is their expectation. Some people have given far more aggressive projections. I tend to be kind of in this school of thought where Avendas is, so I'm showing you this slide. Next is e-rickshaws. Sky is the limit. It's just that they're not being permitted. So wherever they are permitted, they'll become 100%, right? So e-rickshaws is a no-brainer for everyone. Then autos, we are expecting them to become about 20% in 2025. So India currently, pre-COVID, COVID has ruined all numbers. But pre-COVID, India used to make about 500,000 three-wheelers, autos. Out of that, we are talking about 100,000 being electric. The funny thing is, it's already happened now. This year, the three-wheeler electric will be about 100,000. Cars, a long way off, just 2% penetration. LCVs, just 4% penetration. They are more or less the same. And finally, buses, by 2025, about 13-15% of the buses are expected to be electric. So just to rush through the product segments, you have the two-wheelers. We produce 20 million per year. And this year, we do about 120,000. Very good year for them. Apart from this, you also have these low-profile, not very well heard of in the cities, low-speed E2-wheelers. You should go to the interior parts of the states like Tamil Nadu, Andhra, Telangana, and you will see these low-speed two-wheelers which run on lead-acid batteries. They already sell about 100,000, but it's the informal market. It's not, doesn't require registration. So you really don't have numbers. The next one, e-rickshaws, as I told you, this is the largest EV in the country today, about 1.5 million of them. Depending on the states that open up, e-rickshaws, we've been producing anywhere between 1.5 lakhs to 7 lakh vehicles a year. Auto rickshaws, we used to make 550,000 before COVID hit us. This year, about 100,000 plus electric autos will be produced, mostly for the goods sector. Buses, India in a good year used to buy 50,000 buses, out of which 60% is for staff and school application. This is a new market. It doesn't exist in most countries abroad. We also have what are called Mofussil or peri-urban buses, which are about 20%, and 10% only are city buses, but you see so much of media coverage for the city buses. In reality, it is just 10% of the volume. This year, we are expecting about 4,000 buses to be sold. There's potential to sell close to 7,000, but capacity constraints have been the reason. Not all companies have been able to deliver the orders. Light commercial vehicles, as I told you, it's a long way off. It's dependent on charging infrastructure as well. And trucks, in a good year, India typically buys about 250,000 heavy vehicles. But as of today, there is no electrification and there is no policy in the government, but we're expecting some activity there in the short while. And of course, cars, Tata Motors has really shown the way. They're doing about 10 to 12,000 cars this year. So I'm very proud and very happy that an Indian company has been able to establish such a large market share. Extremely gratifying to know that. I'll skip this slide. I don't think it's very important, but what we need to understand is most of these electric buses have two metrics, two commercial metrics to fit into. First, for their buyer, they have to be at least close to the price of a ICE vehicle, petrol vehicle or a diesel vehicle. So that is called a price proximity. And we are expecting them to happen from 2026 up to 2030 for a lot of the thing. Trucks and buses, it will never reach the ICE price. It will be the total cost of ownership, which will be attractive. The second parameter which customers look at is the cost, the total cost or what they pay monthly for the vehicle EMI, and then the energy cost, the petrol or the diesel. So the electric vehicle becomes more attractive in most sectors. It's already attractive in e-rickshaws and autos. So they've already started taking off. But we are also expecting something similar to happen for two-wheelers in 2024. And for buses and trucks, we are expecting it as early as 2026, assuming the bus does about 200 kilometers a day. It's very sensitive to the number of kilometers that the customer travels per day. So next, technology trends. So if you look at it, I've kind of split it into 3 time zones, 4 time zones, where we are right now, where it will be in the medium term, say till about 2028 or something, and long term till about 2035. And by 2040, we are expecting it to mature and become commoditized like combustion engines. So it takes a long time, as you can see. So in batteries, right now you are with NMC batteries, which is very popular with the Europeans. They're slowly moving back to LFP, which has been the most popular chemistry globally, predominantly in China. And there's no reason for it not to be popular because it's stable and it has got a very good cost advantage and other advantages. So each battery has its own pros and cons, right? It's not as though something is inferior to the other. So it depends on the application. What we are expecting is NMC to slowly take more and more space with its superior density, more life, and the cost coming down. But in the long term, we are expecting sodium and aluminum ion batteries to take over. The reason is aluminum ion really, if it clicks, one ion transfers 3 electrons, while lithium transfers 1 electron. So you're looking at 3 times the speed, 3 times the capacity. So it's a very attractive proposition, but it's got a lot of barriers to be crossed through research and development. Similarly, sodium ion, much easier to buy, and it is not as flammable as your lithium ion batteries. So very, very promising developments going on. And we are also expecting one share of the market to be taken by lithium titanate or sodium titanate cells. Mature technology beyond 2040, the expectation is that it will be solid state batteries, but typically without too much of lithium or cobalt. And finally, you will just have 3 or 4 types of batteries. Just like you have petrol, diesel, LNG, CNG, etc. as fuels for ICE engines, you will have just 3 or 4 types of batteries, and they'll all be commoditized. So, of course, there'll be constant improvements within that commodity, but typically there'll be only 3 or 4 categories. For chargers, right now we are at plug-in charging, and India is a really lousy climate to do plug-in charging, even if it is 180 kilowatt rated, because of the dust and grime and tropical temperatures. It gets derated, and we are able to charge only at 120 kilowatts maximum due to contact resistance and temperature increase. So we are all eagerly waiting for pantograph based charging for at least for commercial vehicles. And we are expecting that pantograph technology to be dominant in the medium term, right? For high voltage, high wattage charging. But for cars and two-wheelers, etc., it will continue to be plug-in charging. And then in the long term, by 2035, we are expecting dynamic induction charging, a very, very interesting technology. That's the picture you see at the bottom right of the screen. Very promising. This is, whether it's a car or a bus or a truck, you just run on that lane, and while you're traveling, it gets charged. And there is no wiring or contact or anything. There's one Israeli company, and there's another Korean company which have developed it, and they started doing pilots globally. Very promising. Overhead dynamic charging is also expected to be prevalent among trucks in Europe. There are a few pilots going on there. Mature technology, we have no clue. We are still waiting for new things to happen, and then we'll probably zero in on those. There's one area for power electronics, silicon IGBTs, moving to silicon carbide MOSFETs. We are expecting the inverter to become a charger. And we are also seeing combined devices. China is showing the way, but there are Indian entities which have developed this. It's not rocket science, it's quite easy. And in the long term, we are expecting it to go to gallium nitride and with high density aggregates. Motors, we are right now with permanent magnet motors. Switch reluctance motors will be entering gradually because they've just been completely revamped in terms of technology and capability. Electric axles in vehicles will become prevalent. And we are also talking about a limited amount of torque vectoring. Torque vectoring is the alternate electric differential. You could call it electric differential, right? So one wheel is torqued differently from the other when the vehicle is turning. In the long term, they're expecting variable flux machines and axial and radial axial flux machines to take over. And some advanced induction technologies are under research. Those are likely to take over. But mature technology, we have to sit and wait. I'm sure it'll get commoditized and it'll become a much simpler machine over time. Because automotive has this habit of driving reliability and costs. The industry, the sector mentality is like that. So we are expecting something really new in motors, which has been fairly stagnant technology for a long time. If you look at data and artificial intelligence, right now we do diagnostics, we do computerized planning, etc. Companies have already started looking at prognostics, automatic planning, driver assistance. Now predictive routing is thought of. So by 2035, we are expecting predictive routing and predictive energy management to come. Lightweighting, I don't think I need to get into. Most of us are familiar. It's just that because electric vehicles are so weight sensitive, in the mature state, we are expecting elaborate use of composites, but with mechanized production, not with human production. Range extenders, micro gas turbines, aluminum air, these are the medium-term technologies, and probably fuel cells and others in the long term. But if the battery technology goes to the aluminum ion level, the number of hybrids and range extenders will be minimal. You will not need these. Battery electric vehicles will take care. So I've given you these areas, but one important area which I'm not covering here because there is not enough happening, and I also don't know too much about, is recycling. So you've got pyrometallurgy, you've got hydrometallurgy, but there are new concepts which are being done, and this is a high potential area for India to do research. Skilling needs, right? So what we see here is the taxonomy of an electric vehicle. So you've got battery, you've got charging system, then you've got your energy storage system, and then you've got your propulsion system. So in each of these areas, there are quite a few subjects where we need to up our skills. This is happening at IIT Madras as well as the other IITs, but we needed to go into aftermarket with ITIs and DMEs being trained as well. So power electronics, power distribution, connected vehicles, mobility planning as a course, energy distribution, electromagnetism, EMI and EMC, electromagnetic interference, and of course, good old electrical engineering is required for this. And if you look at storage, you need electrochemistry. You need to be strengthening your thermal management capabilities. We need to learn microelectronics and power electronics. And of course, good old electrical engineering with material sciences and metallurgy. And for propulsion, it would be electrical machines, obviously, motors. You will need power electronics, control algorithms. So this is where the software starts making a big difference. And of course, good old vehicle engineering and electrical engineering. These are all important skill areas where we have to focus. And at the most popular subject level, namely IT, communication, etc., you have mobility and e-mobility. A lot of new algorithms that are coming up for even shared transit, not just shared mobility, but shared transit. So very exciting things happening there. Now we look at what are the areas where we can do R&D in India for a global leadership. So the country's vision, clearly stated, is a global leader, right? So it is important to invest in manufacturing, but it is not enough to invest in just manufacturing. So there is a big difference there. So we need to look at this. As I told you, some brilliant work done by the government in the last maybe about 5 years, 7 years. The production-linked incentive schemes for advanced chemistry batteries, for the auto sector, FAME2 scheme, phased manufacturing program, demand aggregation, communication campaigns, which have been very, very successful. First-class risk-sharing instrument by Niti Aayog with World Bank. That's a good move for the finance sector so that they can start funding electric vehicles. And quite a lot of renewable energy and energy storage policies under the transformative mobility and energy storage mission, and some really bold actions by the government in charging standards. I'm really amazed. I was part of the activity, and for the first time, India wrote its own new standards. We did not have to adopt it from abroad. We developed what was important for the country, and that's what has been published as a LEV standard. And we'll also be the first country to declare interoperable standards. So we have not chosen to be inclusive. We have chosen to be interoperable, and thereby we will make it more competitive for the common man. So what happens? This is not enough because this is all about the field and manufacturing, right? So global leadership requires additional actions on creating intellectual capital. We need clean slate technology. We need India-centric technologies. We need India-controlled technologies, which we own, and we can do what we want with it. We need to stay at the cutting edge. It's not possible today. We are yet to start. So we need to target being at the cutting edge 3 years, 5 years down the line. But you have to start today. Only then you'll get there. So that's the roadmap in R&D, so to say. And in areas where invention has not yet happened abroad. So we need to work on things which will make a difference and help us stay up. And what is India centricity? No? So monsoon downpours, those guys have um, rain. We have monsoon downpour. And we also have frequent flooding, not just because of the authorities, but also because of the changes in the raining rates. We have dust storms on the up north. We have humidity issues much more compared to the temperate zones like China or Europe. Our city traffic is a nightmare. It continues to be a nightmare. And we are probably one of the few countries where inching traffic up flyovers is required, but with overload. Now, this really stresses out the powertrain. And of course, in some cases, roads have improved a lot in the last 15 years in the country, but there are still roads and terrains where quality is not sufficient. So what do? We de-risk the supply chain, sodium ion cells so that you avoid lithium and cobalt, aluminum ion so that you can take a quantum jump in energy densities and power densities. Use the ample sunshine in the country and use the bauxite reserves to start making a difference, right? And in motors, move away from rare earth permanent magnets and go for motors which are slightly less efficient, but they don't rely on other countries. We need to take care of the tropical conditions. We are a different country with a different weather. We need to build competence. Very important. People skilling is the biggest capital and most influential capital. We need to have multiple plays. You can't just bet on sodium ion and forget about the other and then be left high and dry further down the track. So we need to be having multiple plays. And every year we have to keep revisiting our master plan for R&D. So in what areas can we do R&D? As I told you, electrochemistry, sodium, aluminum ion batteries, electrochemistry once again, titanium reserves, we have quite a lot along the coast of India. So we could look at titanium chemistries which are better for tropical climates. While we wait for hydrogen, it's going to take a long time to make money sense. We go in for flexi fuel, near zero emission prime movers like micro gas turbines. New motor and control technology, I already spoke to you about. Dynamic wireless charging, I spoke to you about. New and native materials. We have some magic materials in India. Jute is one of them. And we should be able to actually convert that into a very good automotive product. It's just that fundamental R&D, I remember Birla Group doing that R&D long, long ago, but it didn't get too far. But there are quite a few areas where India offers interesting materials. Of course, software powerhouse, so we should be able to come up with good algorithm to move people around, right? This is going to be brilliant if you have IT enabling people's movement decisions, and recycling, because it's a new technology, it's good to be there. And we come up with new technology for recycling of packs and cells. So we come back to the TRL, and if we see, you have one eMobility R&D mission by the government, and you have another mission with industry, right? Industry mission will automatically follow if they smell money. So it's not a big deal, but the initial part research, it's the governments globally who make a difference. If you look at the later stages of production and production related technology, this has been addressed very well and indirectly by the policy initiatives already. So we don't need to take action there. That part is done, and it's been done well, to the government's credit. But if you take eMobility core research, the first 5 technology levels, quite a lot of areas for us to work. Battery cells, we need to find something which is free of supply chain concerns, lower cost, higher power density, tropical condition safe, suitable, and with higher levels of safety. Similarly, for motors, free of supply chain concerns, lower costs, robust, tropical conditions. And the good news is, in both these areas, we already have the relevant theoretical knowledge in our institutions. It's not a problem. So we need to start having focused programs. That's the need of the hour. It's not people skills, but actually a well-administered R&D program. India-centric fuel cell designs. Right now, fuel cells are exorbitant, and we need to start work along with the others globally. And we need to start doing this with focus, because the costs are really high, and platinum is not a good thing to have around. As I told you, Indian materials for lightweighting and for recycling. So these can be put together as maybe 15 projects across the country, 2 projects competing with each other. And then once it's done, for those items which have completed TRL 5 with this government mission, that tech, just like ISRO gave the cell technology to many companies, this can be given to many companies who will take it from there, and they will do their own further technology development and tweaking, right? And then they will take it to the market. So this is one. But there are also projects or products where there is potential to do TRL 5 to TRL 8 work. And here you're talking about things like aluminum air. IOCL has already signed up with an Israeli company, and there are solutions that are possible without any membranes and with just oxygen cylinders. So we can work on those. IIT Madras has worked on a microgas turbine, which is lean burn. It's multiple fuel. The same truck can load diesel in one place. It can use CNG in Vijayawada. It can use LNG in Calcutta, and it can use hydrogen in Delhi. And it is the same truck just traveling. So it's multiple fuel capability. Mr. Gadkari has been talking a lot about that kind of competence. And dynamic induction charging, we need a few pilot highways and implement it, because it reduces the battery content drastically. So what does it involve? That gold orange box is going to cost the government less than 2,000 crores in 5 years, over 5 years. It's not 2,000 crores in 1 year. And remember, FAME and the PLI scheme put together is 55,000 crores in 7 years. So there's a lot of money that has gone in. It is important to find about 10% of that money for intellectual capital. That's the point I'm trying to make here. So one example of goal setting for R&D missions, I basically use what most companies use, a spider chart. So if you have a battery and you have all these parameters, right? Cost and life and number of cycles, supply chain security, charging rate, blah, blah. So you have an NMC chemistry, which is like this. So it scores high on specific energy and energy density, but it is absolutely lousy for supply chain security. So it's very zero score there is what I've given it. Now, if you look at LFP, the one with lithium, iron, and phosphorus, the supply chain security improves, but the specific energy reduces. But what does India need? India probably needs something like this. That white line shows that we are going to be very good with thermal safety, very good with supply chain security, and very good with upfront costs, because that's what is important for the Indian consumer and the Indian market. I'm willing to compromise on the specific energy and energy density for that sake. If somebody wants a higher density, they can go and pick up a chemistry which is already there. But this is my India bulk chemistry, so to say. I've called it Indion or whatever. But now, is this possible? I don't know. I think that's the idea behind research. So you start the work with a plan, and if it doesn't work, it's part of that 85%. But you have to have that attitude and approach, which is, we are not structured for this yet. As a country, we don't have systems which will do this. Special projects like your Green Revolution, Operation Flood, we have had these kind of things happen. But as a regular activity, it's not very, very common in India. Similarly, for motor and controller, if you look at the permanent magnet motor, it has got certain properties in terms of power density, specific power, noise, efficiency, reliability, etc., right? But if you go further, India probably doesn't care that much about specific power or power density. We care more about thermal management because we are in the tropics. We care more about reliability because our aftermarket practices are not very robust. And we don't want any supply chain risks, and we want cost to be the best. So the white line is the product that I would target for India, and which motor technology fits into that? Fits into that. And that becomes my, I'm not saying it'll be the only motor, but it'll be the predominant motor technology, right? So it's not to rule others out, but it is to focus on what is best for you. Now, this kind of thing happens with concrete administrative efforts. So the technology and the people, I see it to be less of an issue. I see the administrative levers to be the biggest issue as of today. I think what we need is an empowered mission group, something similar to Green Revolution or Operation Flood. What we need is an organization like DRDO and ISRO, which is allowed independence and which is allowed to work in the intellectual community with its own agenda and practices. We need new or existing PSUs to engage in the initial R&D phase so that the whole thing can be monetized. The PSUs are better at monetizing things. So you have already Power and Petroleum Ministry PSUs are taking a lot of initiatives, hell of a lot of initiatives, whether it's NTPC or IOCL or HPCL or Bharat Petroleum, lot of initiatives. And we go the European route. We can tweak it, but instead of designing a new system, there is no shame in copying another successful mechanism. The Europeans have two parallel competing projects for each technology, and it's always bid as a consortium. Academia and industry bid for it together, right? And two people are awarded. And we have to build in failure scenarios. You cannot guarantee success in the research phase. And we should have the guts and the wherewithal to stop projects if they are not successful and absorb the losses, right? One way of going about it is to have limited tenure centers of excellence, which are actually run by industry, but with the umbrella and protection and practices of academia. Difficult to conceive in our current system, but it's going to be very productive because that's the like the Warwick Manufacturing Group is a classic example. They've broken the earlier academic system and brought in new practices. And of course, intellectual property, there'll be a lot of arguments and a lot of concerns, but it is possible to overcome it with 4 or 5 pre-approved models. It's not, it's just, the objective is country being independent. So I'm sure everybody will be able to find common ground. And we need to partner other like-minded countries. It saves time and it also reduces risks. And I think the best example of this is the BrahMos missile program. Brilliant work. And today we can compete with anyone in that sector globally, right? So I think that brings me to the end of the presentation. I hope it's not too late. Yeah, and remember, as I told you, this is just a sketch. We will have to figure out many more of the details, and some of the proposals here might be wrong and we'll have to correct it. But if you don't make a start, you never finish, right? So I think I'll finish with this, and we have another 10 minutes or so.
So thank you, Professor Karthik Athmanathan. So for a very interesting and inspiring lecture. Now I will request Professor Shankar Ram to take over to moderate the question answer session. Thank you.
Thank you, Professor Narayanan. Thank you, Professor Karthik, for the excellent talk. So I'm just going to read out the questions in the order in which they have been received in the chat window. May I also request participants to feel free to type in their questions in the chat window, and we will go through them one by one. The first question is from Professor Sudarshan. He asks, my question is on your take on how green is EV. As an internal combustion engine guy, I kind of find it difficult to buy the green argument, as one would pollute elsewhere to charge the batteries.
This is now resolved, so there is no opinion here. You have facts published. Even if you take coal-fired energy from the grid and charge EVs, it is proven to be marginally superior in terms of emissions to a combustion engine. This is proven. There is still a lot of qualitative discussion, but all quantitative discussions have closed, right? So this is something, as a combustion engine girl, I love that. I simply love that attitude. Don't give up combustion engines. They're going to be here for another 20 years. And they are probably the most brilliant machines I've seen after aircrafts. So but believe me, EVs are greener. Battery electric vehicles will be greener, even if you have coal plants. So I hope that kind of answers your question.
Thank you. I'll just read out the next question from Professor Narayanan. Will EV completely phase out internal combustion engine vehicles? What about applications in aerospace applications?
I don't think we have full clarity to actually take a call on that. It's going to replace a huge number of road-based vehicles, no doubt, and to some extent short distance water transport. Air transport as well as long distance water transport, we do not know fully. But even in road transport, if you look at off-road vehicles, electrifying them completely, it's going to be a nightmare. You're talking about some vehicles made by Caterpillar and all these guys, which use immense power, and batteries may not be able to deliver that kind of sudden surge in power. So you might have to go in for hybrid batteries, where you have high energy batteries and high power batteries. But it's a journey, as I told you and I showed in the slide. We are going to have to discover this, but it's very clear that quite a few sectors will become completely battery. In those sectors, it's a no-brainer. But balance, the jury is out. I don't think any of us have enough information or data to make a clear decision on that. Sorry about the very vague reply, but that's what it is.
Thank you. So the next question is from Dr. Mudali. How do we take care of materials requirements, both conventional and specialty?
I'm not sure I understand the question very well, but if you noticed, people are moving away from materials which are difficult to find. So whether it's rare earths or lithium or cobalt or nickel, these are not very common materials. While in the Earth's crust, aluminium, sodium, these are all more common materials. And people want to avoid the other chemistries. So if you're talking about battery chemistry, if you're talking about motors, once again, rare earths are difficult to find. So people are trying to move away. In fact, some people like Tesla moved away and then came back to rare earths. So this is, as I told you, it's going to give us some level of clarity probably in the next 5-7 years, when the next level of R&D results are known.
Thank you. So the next question is from Mr. Karthik again. Do we have vehicle-to-vehicle charge, vehicle-to-grid charge capabilities? This question is because we have a good market for commercial vehicles, like you mentioned. School buses, office vehicles will have more rest time than operating.
Yeah, this is just a matter of putting in the hardware and software. So I think the R&D part is all done and sorted out, right? So the engineering and implementation is there. In fact, I know that Research Park, IITM Research Park has started vehicle to grid already. And I would say that they are at least 4-5 years too early. But if IIT doesn't start 4-5 years before, who is going to start? So vehicle to vehicle, vehicle to grid, it's not a big deal. It is doable at all levels of vehicles, unless you're talking about small cycles and stuff like that. But I think vehicle to grid, what will come first in India will be vehicle to home. It will not really go into the grid, but the vehicle will start supplying to your own home. And this is a very powerful tool, because then you start looking at microgrids being far more attractive than running all that copper all across the country. So I'm quite sure that this is just a matter of time. The technology is there. It's only development, engineering, and marketing.
Thank you. Next question is from Dr. Prasandeep Ghosh. What is the reason for slow EV adoption in car segment?
I think it's only money. So if it makes money sense to the consumer, he will start buying. And as of today, a consumer has to drive at least 250 kilometers every single day if it has to make money sense to him. Once all charging infrastructure, all that talk is there, there is enough and more being done. The minute it starts making money sense, somehow the charging infrastructure will come. You can bet on it. The market will react. The businesses will react. As of today, it's not picking up because it's just too expensive upfront and you don't save enough on fuel cost unless you do 250 kilometers per day. Then it makes money sense and you will definitely buy an electric car. You will not buy a fossil fuel car.
Thank you. There is a follow-up query from Dr. Mudali, who has mentioned, let us take the example of sodium. So maybe if it is okay, may I request the host to unmute Dr. Mudali so that he can discuss with Professor Karthik orally? Will that be possible?
Yes, sir. Who, sir? Mr. Ravi? Sorry, sir, I couldn't get his name.
Dr. Mudali, Mudali, Kamachi, Mudali.
Kamachi Mudali, sir.
Yes.
Yeah, he's now unmuted, sir.
Thank you, Dr. Sankar Ram. Thank you, Dr. Karthik. It was a wonderful
Your
talk.
volume is slightly low, at least for me.
Yeah, for me as well.
Are you able to hear now?
Yes,
Much
sir.
better.
Much better.
Thank you.
Please.
Yeah. Thank you so much for a wonderful talk. See, I am concerned. I'm a material specialist. I'm concerned about even a conventional material like sodium. Sodium is required in huge quantity if you're going for application in the battery or any other way. But in the country, I don't think that today anyone is producing in bulk quantity in the industrial level.
See, the way we look at it as technology priority is it available on Earth's crust? So we have the sea and sodium is available in much higher proportions than lithium. Now, how it comes out of the sea, what happens is, of course, we've got a lot of sunshine, so we should be able to figure out a way of doing it in a renewable manner. And the idea is to pull the sodium from the sea. I agree, it's not being mined or it's not being generated much, but then you have a lot of it. Lithium, you don't have so much of it. So that is the influencing thought process. The thought process is not, is it being produced? The thought process is it available?
Sir, actually, I will add one point that sodium generally is available as an electrolyte in the earth's crust, sodium chloride as a salt. And you do electrolysis using some Downs process to try to get industrial grade sodium, then that can be purified for any other application.
Lovely.
And I want to tell you proudly that Department of Atomic Energy is taking in a very big way. There is a plant coming up with 600 tons per annum at Baroda, heavy water plant. But what I'm seeing is that there is no one else in the country is making effort to produce, a common metal like sodium that can be done by a specialty technique. I know very well that NML, as National Metallurgical Lab, has made a technology sometime back in a small way. There are no buyers and there are no one interested in making such even conventional metal like sodium.
That's the bottom line, right? If there are no buyers, nobody is going to make it. So we will have to create buyers by establishing a sodium-based technology so that there is a need for sodium and therefore the buyers start growing. But it's great to hear that there is good tech available and from a respectable institution like Atomic Energy. So looking forward to working on that front when the sodium battery is proven first. Yeah.
Thank you.
Thank you.
Thank you, sir. So those are the questions that have been typed in the Q&A box and the chat box. If there are any further questions, may I request the participants to ask them now? So,
I'm inviting all the attendees, sir, if anyone want to ask.
yes.
एक दो करोड़ वो लोग एक बार देख लेंगे but
Yeah, muting is going to be very embarrassing.
Okay.
It is mandated to wear masks
So,
Yeah.
I just wanted to have one question, please, if you allow.
Yeah, sure.
Yeah, so how much would be the load on the grid? EVs. Would it be a huge volume? Is it something to be concerned about? Any estimates?
See, from what I have seen, I've now seen reports from about 6 or 7 countries, right? It is not a concern because finally it came to only about 7% or 8% of the total energy offtake as of today. So it's not a big chunk of the energy, but the timing at which it is pulled out is the concern, and that too at a local level, not at a generation level probably, but probably not even at a grid level, but at the distribution level, right? So this is a problem predominantly for developed countries who have robust infrastructure, where you're used to just connecting to the grid, which is at your on your street. In India, we don't do such things. If I have to set up a charging station, I will measure, and then I have to necessarily take a 2 kVA line and bring it and put up a transformer yard. We are way behind on infrastructure on grid. So actually we do the calculations and we bring it in, right? So I would not call it a concern either abroad or here. I would look at it as a topic which should not be neglected, and it has to be managed. So you have to plan for it and bring it, but otherwise the total energy is very low, sir. It's the energy required for EV transportation is hardly 10% of the total energy requirement of a country. Broadly, that's how it is coming in.
Thank you.
Professor Karthik, there are a couple of more questions in the chat box. May I ask them? No, sir.
Yeah, sure. I mean,
Yeah. So one question is from Mr. Siddesh Vijay Kumar. There was a statement on multi-fuel hybrids. Has any work commenced in that direction globally? This sounds very exciting. Does this mean one engine with multi-source of fuel is to be the order of the day rather than pure EV?
There are two aspects to this. One is the engine, combustion engine. Now, the combustion engine is capable of taking multiple fuels only to a very limited extent. Otherwise, you have to redo. So same engine and same vehicle cannot keep loading different fuels in various places. The combustion engine cannot work that way. But if you look at micro gas turbine as any gas turbine as a prime mover, for that prime mover, it is not that big a deal to change the fuel. So it processes all the fuels very easily the same way. But a combustion engine is a very different, it's a really sophisticated piece of machinery. So it offers phenomenal performance, but it comes with its constraints. So these are not engines, these are turbines.
Thank you. So another question from Mr. Vishwamohan Kumar. As you almost covered all EV-driven data, but for charging infra, making our climate agreement in consideration, can we generate enough renewable energy for trucks when it comes in a huge numbers in the market, or do we need to depend on thermal power generation?
See, I don't think you can depend on renewable energy directly, but with some energy storage, you can address the requirement of the total country because the country uses energy in a cycle. There is one annual cycle where winter and summer usage is different. And there is a daily cycle where day and night usage is different. And there are weekly cycles where weekend usage is different from weekdays. So this is a complex situation, right? Mercifully, we have data. So we know how the consumption will be. So if you generate renewable power, if you look at wind turbines, they might generate throughout the day, but they will not generate throughout the year. Some seasons you will not get enough breeze. So what do you do at that time? So you can't just rely. So what happens is your renewable capacity is not capable of matching these things as well as the other generation things. And there, to assume that thermal power is the only option is wrong. If you are like like Quebec in Canada, they have 95% renewable, but it's all hydro. So they can actually take care of all these fluctuations without batting an eyelid, right? But we don't have so much of hydro in India. So we'll have to take a judicious call as we go further down in terms of how much nuclear we'll take and can we be handling it responsibly, right? And there might be some level of thermal power, but it may not necessarily be coal. We might migrate to a situation where we use the same coal to extract combustible materials and use it at a better, less emitting level. So this is all going to evolve. Renewable is not just solar and wind. Hydro is also renewable. We don't have enough, and solar and wind cannot take care of these fluctuations, which are daily, weekly, and annual cycles. So we have to be careful in mapping this. Right now, this generation is so low that whatever you generate, you just store and sell and it'll happen. But as it becomes bigger and bigger percentage, I'm sure we will start complaining if we don't manage it well. We'll have failures.
Yeah, thank you. So Mr. Mukesh Bhandari has thanked you for the talk. And Mr. Vishwamohan Kumar has requested whether the presentation PDF file could be provided. I think that's something we will take care of.
Yeah, we'll discuss with the organizers and then take a call on that.
I think those are the questions right now. Thank you, Professor Karthik, for patiently answering all the questions, and thanks to all the participants for the interactions. And may hand over back to Professor Narayanan and Professor Nandita.
Thank you, Professor Shankar Ram. Now I would request Professor Nandita Dasgupta to end this session with a formal vote of thanks. Professor Nandita Dasgupta.
Thank you, Professor Narayanan. I hope I'm audible.
Yeah.
So on behalf of the INAE Chennai Chapter, it's my pleasure and privilege to formally present the vote of thanks. I would first
Professor Nandita, can you come on video? Can you switch on your video?
Yeah, sure. So I would first of all like to thank Professor Karthik Athmanathan for giving such a wonderful and very thought-provoking webinar. I'm sure many of the audience present today, they have got a good picture on the e-mobility in India, and maybe it'll initiate a lot of research in this very interesting area. I would also like to thank the office bearers of INAE, particularly Professor Manna and Cornel Rai, who have been encouraging us to revive the Chennai chapter of INAE and start this series of webinars. Professor Karthik was very kind to accept our invitation, and I would really like to thank him especially for that. I would like to specially thank Mr. Rahul from INAE for making all the arrangements, facilitating this webinar, and without any glitch, I must say. So thank you very much, Rahul. You have done a wonderful job. And yes, I would like to thank Professor Narayanan. He has been an inspiring person behind all the activities of INAE Chennai Chapter. And of course, all the members of the Executive Council who have all chipped in with their bit, particularly Shankar Ram, who contacted the speaker and also acted as a moderator today. And finally, last but not the least, I would like to thank all the participants for making it a very interactive and interesting session. Let us hope that we will be having more such sessions in future. Thank you very much. Thank you, everybody.
Thank you. Good day.
Thank you, Professor Nandita Dasgupta.
Thank you.
Yeah. Mr. Rahul?
Yes, sir.
So you can formally possibly close the session the way in which
Yeah. Okay, thank you for this wonderful lecture, sir. I hope people will have gained some knowledge about this. So thank you very much, sir.
You're most welcome. Thank you. My pleasure.
Thank you and good day.
You too. Bye-bye.
Thank you. Can we leave the meeting.
Yeah.
Yeah.
Okay, bye.
Bye-bye.
Bye, sir. Good day, sir.
Bye. So, yeah.